Hey class, welcome back to Introduction to Ethics. I hope you're all doing well today. In today's PowerPoint, we'll be looking at the ethical issues that deal with biotech, genetics, and cloning. Stay tuned for the PowerPoint.
Now for Chapter 7, Biotechnology, Genetics, and Human Cloning. And where we have to start basically with the introduction or the starting point for genetics and biotechnology for this PowerPoint is the Human Genome Project. And this was a project that was about 13 years long, 1990 to 2003. And the Human Genome Project has provided a tremendous amount of genetic information for researchers to work with. They were able to really get a good detailed look at the gene map for human beings. And researchers through this project now know that many diseases are results of specific genetic links. And so what happens is when scientists want to fix those genetic links, it can cause ethical issues. The new knowledge has raised many complicated moral issues. And you can even see, this is their symbol for the Human Genome Project. And over there on the far right of the screen, you see it even says ethics around their symbol, because it does bring into ethics. If you look down to the bottom left, it says engineering. So you're starting to think about going in and changing genes to where you're engineering a different type of human. Let's say, for example, you're going in to develop a designer child. You want to have a child with certain color hair or certain capabilities, and going in and changing their genes. And so it does raise ethical issues. Let's just continue on. The Human Genome Project, the goal of the project was to map the entire human genetic code. And when they did this, they found that there are genetic links with certain diseases. And there are two types here. These diseases that are directly caused by genetic links. That's the first yellow highlight on the screen. And then the second yellow highlight is diseases that are indirectly linked to specific genetic markers. So let's look at the directly caused first, the one towards the top. It says there underneath, the person will get the disease. So if they have that genetic link, if it is found, then that person will get that type of disease. So that would be like an inherited disease. The parents have it, the child will have it. And for an example of that is Huntington disease. It's inherited disease that causes the progressive breakdown or degeneration of nerve cells in the brain. And it will eventually lead to death, but usually it begins in the late 30s, early 40s, and everything was going fine up until then, and all of a sudden Huntington's disease kicks in, and the brain just breaks down, and there's all kinds of difficulties, and then all the way to where they end up passing away, and usually in their 50s, and then that's the first where an example of the first where that's directly linked genetically. But then there's diseases that are indirectly linked to specific genetic markers. And this is where the person may possibly get the disease. It doesn't mean they will get it, but it possibly get it. And an example of this is breast cancer. There's belief that there's hereditary links. So if women in the family, grandmother, mother, if they had breast cancer, then there's a possibility that the child would also possibly get breast cancer. And the Human Genome Project, they believe they found some links genetically with two of the markers that is basically a mutation of the marker. Indirectly linked marker is a possibility for the disease. And so that gives us this information. And the information is not bad. We have this information. But the thing is what do we do with the information? The knowledge of the human genome raises a number of important questions relating to how to deal with this new knowledge. And the two questions that we're going to ask for our purpose here is, number one, do you want to know? And number two, what will you do to prevent it? So for example, our first example with Huntington disease, the question is, would you want to know? What will you do to prevent it? So let's look at that question there. For example, breast cancer. That was our second example in the previous slide. What will you do to prevent it? Well, there's accounts that women that have a history of breast cancer, they might get it, but they'll take steps to prevent it. And even though they've never been diagnosed with breast cancer, they have a double mastectomy and have both breasts removed, even though they don't have the cancer. So, these are the two questions that we start thinking about, and this comes out of the Genome Project. One thing that we can do to know certain issues that may come up is through prenatal testing. And again, this is going to bring up more ethical dilemmas or ethical issues. Prenatal genetic testing is common practice in prenatal care. And so the first one, ultrasound imaging, that happens all the time, several times throughout a woman's pregnancy. She can have ultrasounds, and it shows the baby growing or the size, and they take measurements, and they can even tell the sex of the baby through ultrasound. But that's the least invasive way. But then you start getting into blood tests and looking for disease or genetic issues through the blood tests. And then the most invasive is amniocentesis. And amniocentesis is going in and taking some amniotic fluid and having that tested for certain types of diseases or genetic issues. So amniocentesis is the most invasive and does pose a slight risk to the baby's health, to where there's an issue there just with even carrying the baby. But it's just a slight risk, because amniocentesis, it does occur. It also can put parents in a moral dilemma if the test returns with bad news. And so that's the big question. If it comes back that the baby has a genetic issue, what do the parents do? Will they choose to terminate the child in the womb and have an abortion because of a genetic issue? And many times an abortion does take place. A high percentage of children that are diagnosed in the womb with Down syndrome in Europe does end with an abortion. So some believe, because of that, the test should not be conducted at all. That basically just let nature play its course and give birth to the child without having those tests. Okay, so we're just going to move now into biotech and sex selection. Like I just said, there's ways to see in the womb through ultrasound the sex of the baby, but what about if you could choose the sex of your baby before the baby is even conceived? And so that's where biotech and sex selection comes in. Just like IVF and prenatal testing are akin to prenatal genetic testing, so you can get very detailed here in what you're looking for, like, say, a defect, and you can see that in the lab and all of that. A couple can also simply choose which embryos to implant based on the sex of the embryo. So if they look at the genetic makeup of the embryo and they can see what sex the embryo is, and the parents, let's say they want a girl, then the boy embryos would just be set aside, either put into freezing or just discarded. And we've already looked at the moral implications with that. So they could just choose which ones to implant. But then there's also this process called microsort. And basically, as it says there on the screen, it's sifting the man's sperm to be able to find the sperm that would give the best chances for a certain sex of child. It is less reliable, as it says there on the screen, 85 to 90% chance of success, which that sounds high. But if you're wanting a child of a certain sex and you've paid for this procedure, and then 15% of the time it could be not the right sex that you wanted, now all of a sudden there's those issues that come up. I mean, actually, parents would be like, well, we didn't want this child, and the amount of money we just spent for this. And so you start seeing the issues that pop up through sex selection. And really what it is that this is done through investigating the genetic properties of the sperm. And they find the genetic properties that would be a boy or a girl, and then they insert that into the egg. Using this sort of technology does not necessitate that the choice is due to preference of sex, but may be to limit sex-linked genetic diseases. So what that means is, let's say there is a history of breast cancer in the mother's line, and they decide, well, you know what, we don't want to have a child that may grow up and have breast cancer. So what we'll do is we'll have sex selection. We'll just only have boys, so we don't have to, bring up a girl that may have breast cancer later on. So that's kind of what that means there on the bottom of the screen. It is not intrinsically wrong to desire a child of a certain sex. That question happens all the time. Usually in Christian circles, when the mother is pregnant, it's like, oh, what do you want to have? And they'll say, well, I'd like a girl, but really I just want to make sure that the baby's healthy. You'll hear that from people. So it's not wrong to desire a child of a certain sex, but this is very important. Everyone must understand that no matter what sex the baby is, boy or girl, the child is to be considered a gift from God, no matter what the sex. God is sovereign, and God has given a child to a couple and a husband and wife, and they have a baby in the family. That is a gift from God, no matter what the sex of the baby is. Okay, we're going to move on now into gene therapy. This is like a next kind of topic that we're going to talk about here in this PowerPoint. Gene therapy, it offers some of the most exciting aspects in genetics, because you can get in and change things in the genetic code to prevent some sort of genetic disease. And so it's kind of like almost like genetic surgery, going in and fixing something if there's an issue. So gene therapy holds the promise of providing treatment for some genetic diseases. Now, just by saying that doesn't mean everything is ethical. There's things that would be okay, just trying to fix something, but then when you start breaking past that boundary and now you're moving into unethical things, that's where the issue is. That's why even on the Human Genome Project, they had that on their symbol where it said ethics, because they knew that you go in there and start messing around, it's going to change. It can bring ethical dilemmas and change things up that you can't unchange. So there are three main forms of gene therapy, and we're going to go through each one of these a little bit. We have gene addition, germline therapy, which involves a process which is called CRISPR-Cas9, and then gene replacement. So we'll go through these here briefly. Okay, so here they are. Gene therapy, you can also call it gene splicing. Maybe you've heard that before, gene splicing. But here's the three main forms of gene therapy. There's gene addition, which is a process to counter a genetic defect by adding a correcting gene to the body. Okay, so that's called gene addition. That's pretty simple. You add a corrective gene. But look underneath there, note, it only affects the immediate patient. So that's kind of like the least invasive for anything else. You're just dealing with the patient themselves to try to correct something in their body through the gene addition. Okay, and so it's not really affecting anyone else like number two. Germline therapy is the corrective gene is inserted into early stage embryos or even into the sperm or into the egg to correct a defect on that level. Now here's the issue. Unlike gene addition, the germline therapy, it passes the code to successive generations. So it's not just limited to the immediate patient. It's going to be passed on to the children and further on as the generations continue. So what is taking place in the lab today could have consequences 2-3 generations from now and affecting those generations. And as you see here where my arrow is on the screen, right there are unknown effects of the altered gene code. Okay, so you just wouldn't know. It would just you change something today, and 35, 40 years from now, someone is having some kind of serious defect because of what was done today. And then there's also gene replacement. Now this is where the defective gene is cut out and replaced with a corrected gene. It's kind of like gene surgery. You go in and you cut something out and put something else in its place. And that's where we get to this process called CRISPR-Cas9, which is basically how gene replacement takes place. CRISPR-Cas9 means clustered, regularly interspaced, short palindromic repeats, and it's pronounced CRISPR. And the good news for you is you do not need to know that for the exam. You will need to know what CRISPR-Cas9 does, but you don't need to know that long name. And then Cas9 it's the name of a protein. It's called Cas9 protein. And what it is, it's like surgery on the genetic level. So what is this? What is CRISPR-Cas9? What does it do? And really what happens is the process edits genes by precisely cutting out DNA and then letting natural DNA repair processes to take over, involving the Cas9 protein and RNA, which RNA is the single strand of DNA. So DNA, it looks kind of like a twisted ladder, and there's two sides to it. And it kind of, you may have seen pictures of it. I should have put one on the screen, but it looks like a twisted ladder. Well, RNA is like half of that. And so using Cas9 and RNA, the DNA repair process actually repairs the cut out piece. And that can lead to other issues. So for example, as you see on the bottom of the screen, the process can lead to curing disease. And so I'm not saying that it's bad. It can lead to curing disease, but also ethical issues come up where there's some that it could lead into mutations and safety of the person that is being worked on, that their DNA is changed and then mutates, and then all of a sudden there's another issue that would not have even happened if they didn't do the gene therapy. But this can also lead to what is called designer children, going in and cutting out a certain trait or a gene that leads to a certain trait, replacing it with another trait that the person might want for their child. And then thirdly, undermine that children are gifts from God. Again, especially if you're thinking about designer children, if you just have a child the regular way and it's a gift from God and you just love that child and the child grows and learns how they learn and does sports, how they do sports or not do sports, maybe they're into music. It's just that child and it's a gift from God to that family. But when you go in and you start messing with things, I want this, I want that, I want a girl that has musical talents and is going to be 5 feet 10 inches tall and whatever. Next thing you know, you're really messing around with their DNA. It's just undermining that the child is a gift from God in the first place. Okay, so let's continue on with gene therapy. This type of technology is still in its infancy. This is, again, some of this stuff you would think is like almost like science fiction, but here we are. We are now able to do different procedures on the actual genes of people, the very small makeup of the person. And even though they did the Human Genome Project, it's still in its infancy. If gene therapy fulfills its potential, it could mean a cure for many diseases. However, one fear of gene therapy is that it will not be used for treating diseases, but for illegitimate enhancements, such as altering a child's height or intelligence or whatever. And that's where we get designer children. And you'd be like, well, the person's, they're kind of into themselves. They want to have a baby that's tailored exactly to them or whatever. And we would say that's ethical issues there. But like I said, some of this, it starts thinking about like science fiction where, 50 years ago, you wouldn't even be, thinking about going in and splicing people's genes. But there might have been, movies made or something of people like being a super soldier. And that's kind of like where it could go. Who's to say that in 50 years from now, the science fiction of today is actually coming into reality, and where they're trying to create people that are can live longer, have bigger muscles, have more endurance, whatever it is. And so you think of like a super soldier type idea, which again is like science fiction today, but with science, things can really push the envelope. The line of demarcation between legitimate and illegitimate enhancement is unclear. Which brings us into our final portion here for this PowerPoint, human cloning. And again, human cloning, you would say, well, that's like science fiction, but it was science fiction until all of a sudden they cloned a sheep called Dolly. And next thing you know, they have cloned something. So, and it didn't last long that it was like, hey, let's start thinking about cloning people. So what it is, human cloning is the process by which a child who is born is the identical twin of the adult that the genetic material was taken from. It doesn't necessarily mean to be the clone of the mother that gives birth. It's just the clone of the genetic material that was used to bring the sperm and the egg. It's the clone of that was brought together. And so what really, it's in the technical term for this is somatic cell nuclear transfer. What it's usually called procreative cloning is what it's called. Okay, well, obviously there's going to be ethical issues with this because number one, not just even talking about, should we be doing it or anything like that, but there is just flat out, there is significant risk to the embryo, fetus, and perhaps even the woman who carries the cloned person. So it's very risky, and going in and people, this is where people say, well, we'd be going in, we'd be playing God. When they did the cloning of Dolly the sheep, they failed like 250 some odd times. They failed over and over and over again. And so if you start doing that with people where you're failing over and over and over again, well, those are people. An implanted embryo or the cloned embryo, well, that's a person. And then all of a sudden it fails because of some kind of mutation or some kind of an issue that takes place with the cloning. And then all of a sudden you have this embryo, which is a person, is now dead because of this human cloning procedure. Okay, and that is it for Chapter 7, Biotechnology, Genetics, and Human Cloning. We're only having one PowerPoint for this chapter. We're going to be having a short video for next session with looking at CRISPR in more of a more detail. It's a neat little video, kind of helps us understand what that means with gene replacement. Okay, I'll see you in a second.
All right, class, that's it for today. Next time, we're going to begin our look at ethics at the end of life. I'll see you then.